Experiments are a key step in the scientific process. To conduct a successful experiment, the scientist must know how to design, plan, and execute an experiment. All scientific investigations must be carefully planned and executed. One of the most powerful investigative tools is the controlled experiment. A controlled experiment is specifically designed to measure a specific variable or change. The aim of the controlled experiment is to manage the variables. Variables are observed values obtained during the experiment that typically change during the course of the experiment. In a controlled experiment, the two types of variables are the independent variable and the dependent variable. The independent variable is an aspect of the experiment changed by the researcher. The dependent variable changes according to values of the independent variable. A well-designed experiment has only one independent variable. The single variable enables the results of the experiment to be attributed to that cause alone. A well-designed experiment also consists of at least one control. These aspects of the experiment are unchanged and purposely kept constant. The controls allow the experimenter to isolate the effects of the independent variable on the dependent variable. The controls therefore allow the experimenter to infer cause and effect from the results. Consider an experiment in which a scientist studies the effect of sunlight on plant growth. The hypothesis to be tested could be sunlight causes plants to grow. The independent variable controlled by the scientist is the amount of sunlight a plant receives. The dependent variable would be how much the plant grows. Since the desired measurement would be plant growth with respect to sunlight, other possible variables need to be controlled, which usually requires them to be kept constant. In the plant experiment, the scientist would control the type of plant, amount of soil, amount of water, and amount of fertilizer to isolate the effect of sunlight on plant growth. A controlled experiment usually includes the absence of that variable. In this case, since sunlight is the variable being tested, the control would be a plant that received no sunlight. This plant would verify whether sunlight actually helps a plant to grow. One way to do this could be to place a plant in a dark room so that it received no sunlight at all. With all of the other aspects of the experiment being controlled, the independent variable must be changed to test its effect on the dependent variable. To test the effect of sunlight on plant growth, the experiment could have several identical plants receiving different amounts of light each day. One design could be 5 plants each receiving 1 to 5 hours of sunlight per day, and a 6th plant receiving no sunlight. To obtain data on the dependent variable, the height of each of the plants would be recorded. Data on the independent variable would be the amount of sunlight the plants received. After observable change had been observed, the scientist would analyze the data to draw a reasonable conclusion about sunlight's effect on plant growth. A well-designed experiment should preferably have only one independent variable. It's possible to conduct an experiment with more than one independent variable, but such an experiment can be difficult to design and to interpret. For example, if the plants each received different amounts of sunlight and different amounts of water, it would be difficult to decide if they grew because of the water, the sunlight, both, or neither. The methods for designing and conducting a properly controlled experiment make it easier to test hypotheses and to draw valid conclusions based on the results.